Hi class. In this video, we're going to look at the building blocks in Java, discuss methods and arguments to methods, and look a little bit more on how to jazz up some output. One of the first building blocks you learn about in Java is a class. You wrote a class last week called Hello World. Temporarily, I'm just going to say that it holds the content of your program, but it's way more than that because a class is actually a blueprint. And when we start covering OOPS, which is next week, you'll learn that a class describes objects. But for now, we'll think of it as the item that is holding your program. So there's things inside of classes, but there also can be things outside of classes. So there could be multiple classes in a library, for example. Something you learned about last week. So the syntax rule for creating a class is starts with the header line first, and that header line is going to say public. It might say private, but public, usually class, and then you get to make the name up. This is called the class header. After the class header, you will have curly brace, and then you're going to put at least one method, and it could be way more than one method. And then after you've written all your methods, you'll put a curly brace in to end the class. So what goes inside of those classes are methods. So a method is a block of code that performs a certain action. A method runs only when called. So you got to tell in your source code, run this method. The exception is the main method, which you saw last week. You did not have to call that method. The main method automatically executes when you start your program running. So let's look at the rules, syntax rules for a method. First of all, you have the method header. Now this is going to vary, and this is what your main method header looked like last week. So it's public. There's other options we'll be discussing throughout the semester. Static, again, that's optional. You may or may not have static. For the main method, you always have static. Void, and that's going to change also. Then you get to make the name up, except for main. Okay, you must have that one main method. So that's the method header. You have your curly brace. Then inside of each method will be one or more statements. And when you got done with the action you wanted to perform with that method, you will then have a closing curly brace. Okay, finally we got to our statements. So a statement is exactly one command. It's exactly one instruction because there are actually many types of statements. I'm not going to explain the syntax of the statement, but all statements end in a semicolon. So a statement could be a declaration, and here is how you could declare a variable called num. It's going to be an integer data type and assign the value of 30 to it, and you see there's the semicolon there. It could be what we call assignment statements. So here we're multiplying that 30 that is in num by 4. It's going to be 120, and then that 120 will be stored into the variable total. You will call a method, and you called a method last week. You called a method from our Java library, and it was called the print line method, and it had an argument of a string. And here is a method for a bad alien object that I'll talk about next week. And that alien, we shot it and it's going to die. So that's the action that alien is going to do. It's going to die. And then we also have flow of control, loops, if statements, which we will be getting to throughout the semester. So when you write a method, only the main method executes automatically. So if you want a method to run, you, the coder, have to tell it in a statement to run. Let's think of the method as being a machine. The process of telling the method to run, we call it calling or invoking the method. And imagine this machine is taking input, working with that input with your statements, and then spitting out the output for you. You do not need to know any of the statements. Let's look back. Did you know what the statements were in the print line method? No, you don't know, but you were able to call it. This is the call right here. So you don't need to know the statements, but you do need to know what it expects as an input and what's going to happen for the output. Okay, back to here. Okay, we want it maybe a string, input a string, and the output will then be, it's going to display this string. There is an analogy backing up. First of all, I said you don't need to know how that machine works. This concept is called abstraction. And abstraction is really big in computer science. We addressed it in our discussion last week on software development kits and APIs. Let's do an analogy of this function machine. We have here from algebra, which I know you know, f of x equals 3x squared plus 3x minus 4. This function would be what's in this function machine here. The input could be 2. Well, if the input's 2, out pops 14. Just plug 2 into the x, right? If the input is 1, if 1's coming in, out pops, you do the math, okay? So the call in algebra, the call would be f of 2 or f of 1. In programming, that input is known as an argument. It's an argument input into the method machine. In Java, the argument is also in parentheses. See, we have the 2 in parentheses here, or the 30, f of 30. And again, we'll look at this from last week. Notice hello world was our argument. It's a string literal and it's inside parentheses. You need to know the data type the method expects, but a good programmer is going to let it flex for you a little bit and allow multiple data types. In fact, the print line method, if you look the documentation up, would allow you to put an integer up there or a string or a character. Here, let me show you. I have, 5 print line methods here, and you notice this argument is an integer, and this argument is a string, and this argument is actually a floating point number, and this argument is a character. This argument, that argument's not going to work. You see how NetBeans is going to show you that argument's not going to work. Why? It looks like a string literal. It's not a string literal because there's no double quotes around it. So if it looks like a string literal, but it doesn't have double quotes, Java is going to say, well, that's got to be a variable then. I have not declared a variable called ASF whatever, and that's why I'm getting this little argument. Notice in NetBeans, if you come over to the side, it's kind of helped me figure that out. Cannot find symbol, variable. So now I know, oh, I don't have that variable, and that's the mistake. Some methods might ask for more than one argument. So I have an example right here, the PAL method, and the PAL stands for take to the power of. It's part of the math class. And there's 2 arguments. Notice that a comma separates these 2 arguments, and this is the same as 3 to the power of 4. So the first argument is your base, the second argument is your exponent. Let's look a little bit more on printing. Remember this statement from our last video, and it was illegal? Suppose you really wanted to output quotes, double quotes. How do you do that? The solution is called escape characters or escape sequences. There are many escape sequences, more than just one for the double quote. And this is how your escape sequences is going to be formatted. A backslash with a T will output a tab. It'll move it over, your output over to the next tab character. You want to go down to the next line? This is the new line character. So you notice all these escape sequences begin with the backslash. So here's how we do the quotes. We do the backslash with a quote. Well, what if you want to print a backslash? Backslash is being used now to indicate the beginning of an escape sequence. You're going to do backslash, backslash. So you're going to put these escape sequences right in the middle of your string literal. So let's take a look at this. So this is going to output what? Oh, a backslash. And then there's a hello. Oh, here's another one, new line. So notice the output goes down to the next line. Okay, oh, there's a T after the how, and so that's a tab there. R, and then there's the quote, U, and then there's another quote, question mark, and then there's 2 of these pairs of backslashes, and that's that output. So that's how escape sequences work. The text just introduces these 4. There's many more besides these 4 escape sequences. We know that there's a print statement. We know there's a print line statement, but you can get a little bit more fancier in your output if you use the printf statement. Printf statement is going to take more than one argument. Remember the PAL? The math.pal had two arguments, the base and the exponent. In the printf, the first argument is going to be what we call a format specifier. And the format specifier is going to go in quotes like a string literal. And in there, you're going to put little formatting characters, and we'll go through what some of those are. The next set of arguments are the data that's going to be going to drop into those format specifiers. So the format specifier is a placeholder, and then the next group of arguments drops into each placeholder. So if you have 3 placeholders in this first argument, and you need to see it, but if you had 3 placeholders in the first argument, then you're going to follow that first argument with 3 additional arguments. That's the data going into the placeholders. Now the data type has to agree. So one format specifier is for a string. If you're going to use that string format specifier, then the data plopping into that placeholder has to be a string. Okay, it can't be another data type. So you got to make the data types agree. The arguments going after the format specifier can be literals or it can be variables. Remember, string literals you're going to put in double quotes. If the argument is numeric, then no quotes around numeric arguments. And if the argument is variable, variables don't put quotes around variables. More on variables next week. Here is the syntax for our printf statement. Notice it's still using the system.out, and now it's .printf. The first argument is our format specifier, and then a series of data arguments depending on how many format placeholders we put in here. In this example, we have a %s and a %s. So all these format specifiers going to begin with a %sign, and that is one argument, and S stands for string, followed by the format specifier. Then I need a string argument that's going to plop into here. Then I need another string argument that's going to plop into here. So we have our initial format specifier argument. This has 2 placeholders, so then we have 2 pieces of data that pop into the placeholder. This actually will be exactly the same as what you did last week, so this is a very difficult way to just print that out. Notice there's no new line here. Notice it's not print line, it's printing on the same statement. Let's take a look at all of these format characters. Now, printf happens as your output gets fancier and more complex, when you're mixing strings and numbers in your output, which is actually pretty common. Your format specifier is going to have a %sign, followed by the format character. And these are the format characters here. If the format characters, if you need to do string, lowercase s, or if you want it all uppercase S, put a capital S here. Or a character, again, if you want to capitalize it, you can use capital C. If you got numeric data, use D for integers and use F for decimals. Think of F as meaning floating point. It's a little confusing. I wish they wouldn't use the D because you would think D means decimal, but D is for integers. And there's other types of data also. There's dates, so if you want to format it to look like MMDDYYYY. There's Boolean. Boolean only prints true or false. What if you want to display a %sign? So there's no /%, there's %%. And then, oh, hey, this is how you get down to the next line, a %n. Think of n as meaning new line. So besides the format characters, which are shown in this table, there are also flags. There's also something for width. There's also a way to do precision. We're not even going to look at conversion characters. So these are all optional. For example, optional flags, special formatting. You need to change justification from left to right. A comma. Comma's not going to automatically output for numbers greater than 1,000. You need to indicate that you want the comma to display. You're going to use the width values when you want to align columns. So width is specified before the format character. So 10s means it's going to be a string, and that string is going to take 10 characters. So it could be just the string by. It doesn't matter. I'm going to have it fill 10 spaces. Helps with alignment, actually, when you're trying to align columns. Oh, I wanted to point out also that it defaults to right alignment when you do the width. You can override that, right? That minus sign changes it to left justify or left alignment. If you're using numbers with decimal places, you want to indicate how many decimal places you want to output. This is especially important when you do division, because when you do division, you know you can have a lot of trailing numbers. So here we're indicating that we want, remember F stands for floating point number, and this means we want 2 decimal places. So notice the percent dot 2F. And then the second argument is this large number with a large number of decimals. But notice what's going to happen. It rounds it up to 12.35 for the L. You can also put text inside your formatting string. It doesn't have to be just format characters. In this case, I want to output a label. Remember when your algebra teacher always said, put a label on your answer. So here we are going to put a label on our output. This is going to output literally number is approximately %.2F. So that's the format character there. And here is our data argument that's going to go into this. This is the placeholder. So if there's not a percent inside of it, it just literally will print out what you see. It's going to take this 12.35, rounding it up because of the precision value there. You can also combine multiple format specifiers. So here, total is, and then I have a $sign before this format specifier. And the first format specifier says, hey, put a comma in here. And then I only want 2 decimals. It's a floating point number, has decimal. But after that, then go down to the next line. And here's our argument. Our data argument will go into this first placeholder. By the way, the new line, it does not expect any data. It just means go down to the next line. So this, because of the comma, is going to display the comma, and this will round up to 89. And that's it. Time to take your quiz over the content of this video. Good luck.